Are you ready? Yes or no? Yes, let's work together. Okay, we don't have time to waste because this weekend you're going to have a lot to do. Tuesday you don't have class, okay? You're going to do study group. You're going to have class outside of this room. Okay. In other words, I want you to, having some group study on Tuesday. On Tuesday, teachers are going to study as well, but we have our own learning day, and so students should have your own learning activity. So you will have a packet for you, for your study group. No in-class session, but you are going to, I don't know, you can find a way within your group, the best way for you to collaborate. Okay? So in other words, you try to get yourself ready. The log, I think in Unit 1, some of you feel like, oh, log is hard. How many of you feel log is hard? Some parted. How many of you feel like log now become a little bit friendly? Oh, okay. How many feel like you just have a little bit not quite understand, otherwise you're fine? Okay, good, very good. All right, so this is like a game. There's some rules that we have to follow. So if you follow those rules, you will be the winner. Okay, let's do the first one, the quiz. Log to the base 5 xy squared over zw cubed. Well, this is a quotient, isn't it? Okay, can you say out loud, what should I do? It will become log, it becomes the difference of logs. So log to the base 5 of xy squared minus log to the base 5 parentheses zw cubed. Why am I putting this parenthesis? Just to remind me, it is all for me and for you to know that actually this is a product. That is a product, right? Okay, how many of you do this? Okay, how many of you try to change this to a product? Great, we will do both, okay? So now let's do this and we will do the other. This is a product, so let's use the product rule, okay? Who would like to be volunteer? It will become what? Log to the base 5 of what? X plus log to the base 5 y squared. Great. Now, how about this? Oh, some of you already see that, oh, there's a power, so we need to come out. Well, we will do that next, okay? Now, minus what? Log to the base 5 z, and then minus or plus? Somebody say plus. Log to the base 5 w cubed. Is this correct? No. That is the reason why we will, we encourage you to write this as a product, but that's okay. What will I do that it will be correct? Brackets. Thank you. So I think that you do know what, you do want to have a bracket. If you do have a bracket, then, so it is okay if you keep this bracket, then inside it is addition, right? Okay? And now you have to distribute. So log to the base 5 of x, and then plus, now you can use the power rule, right? Power rule. You have 2 times log to the base 5 y, and then minus log to the base 5 z, and then minus this. Now I can use this power rule, right? So minus 3 log to the base 5 w. To avoid what we call this distributive property mistake, you probably can write this quotient as a product. It will become log to the base 5 x y squared z to the power negative 1 w to the power negative 3. Now this become a product. By the product rule, it will become what? The sum of logs. So can you say out loud, what would that be? Log to the base 5 of x plus log to the base 5 y squared plus log to the base 5 z to the negative 1 plus log to the base 5 w to the power negative 3. Now we have power 2. Using the power rule, it will be able to take outside, become the coefficient. That is a power rule, right, Nathan? So Nathan, can you tell us the result will be?
Log to the base 5x.
Log to the base 5x plus 2
log to the base 5y.
Log to the base 5y plus, you will have negative 1 log to the base 5z, but plus negative 1 times this is minus, right? And then plus negative 3 log to the base 5w, but of course, we all know it is just this, right? Isn't that the same as before? Yes. Now, how about the problem 2? We are going to find log to the base 3 square root xy over 25z. Again, this is a quotient. So we write out log to the base 3. Would you like to change it to a product? Okay, let's try it. So let's try also taking this square root and write it as a exponential form. So it will be what? Xy to what power? 1/2. So now 25 is 5 squared. Am I correct? So it's in the denominator, so it becomes 5 to the power negative 2. And z is power negative 1. Now this is the log of a product. So by the product rule, we can write it as the sum of logs. So the first one is log to the base 3 xy to the power 1/2 plus log to the base 3 5 to the power negative 2 plus log to the base 3 z to the power negative 1. So far so good? Yes? Now what? Can I use the power rule?
Yeah.
Yes. So you will have 1/2 log to the base 3 xy minus 2 log to the base 3 of 5 minus log to the base 3 of z. Okay? Am I done? No, because what? I still have this x times y, yes? So I have to use the product rule. So I will have what? 1/2. Anybody can tell me? Log to the base 3 of x. And then? Plus?
1/2 log to the base 3 of y.
Great job, Nathan. Nathan did not forget about you do need to have this 1/2 because you have 1/2 times the whole thing here, right? So inside is log to the base 3 of x plus log to the base 3 of y, but this 1/2 need to be multiplied in, right? Great job. How many of you got this correct? How many of you forget about this 1/2? So that's why I'm putting this 1/2 in red. This is a common mistake. Be careful. Okay? Be very careful. Is this a good practice? Okay, number 3. Log to the base 7, 7 to the power x squared. Did you see something? Yeah, this is an exponential with the base 7. That is a log with base 7. They are inverse of each other. Am I correct? So we have to recall f inverse composed with f of x. What do you get? X, right? F composed with f inverse of x. What do you get? Also x, right? Remember? This is the rule for inverse function. So right now, what is the power? Can anyone tell me? X squared. So x squared is the input. Going to the exponential first and then going to the log with the same base. So what do you get it back? The answer is just x squared. Because this, look at this red circle. That is by itself as a whole thing. Are you with me? Not 2x. Why 2x? Okay.
Because 7, since there's 2 7s, it equals 1. Is that why?
Yeah, you will have this. Log 7 of 7. But what is log to the base 7 of 7? It is 1. Or you can look at inverses, right? Either way, you will get x squared. Let me ask you, what is the exponent? Tell me, what is the exponent? The exponent for the base 7 is x squared. So if I'm using the power rule, this is using the power rule, then you consider this power would come out, right? And this is 1. Or you can use this inverses. F inverse composed with f of x is x, or f composed with f inverse of x is x. Then you know, well, since they have the same base, I just get identity. So this should be the same. Is that okay? Are you with me? Either way, you get that. Number 4. Square root. Wow, square root of 2. This is the first time we are using square root number as our base, huh? What is the exponent? It's log. Oh, it's the same square root of 2 as the base. So it's log to the base square root of 2 of 19. What an odd number. So what is the input? Tell me. What is the input? Louder. 19. What is the first function that he has to go through? Log. With what base? Square root of 2. And then he has to go through an exponential function with what base? The same base, radical 2. Therefore, look at this inverse function, right? Go through the inverse and then go through the f. You will get identity. So the answer for this will be 19. Are you with me? Kind of. Okay, let's do number 5. What is the base you like? Give me a base.
Radical 5.
Radical 5. And I'm going to have log to the base radical 5. And then I will say x. Then the answer will be what? X. Thank you. You are awesome. Yes? What if you have different base, right? Then they are not inverse functions. Then sorry. Then you have just say, oh, sorry, I cannot touch you.
So if there's 2 of the same number, they cancel out?
I don't like to hear that cancel is not canceling. Okay? It is inverse, right? You're doing this inverse function. It's not really canceling, because when you say canceling, it could be subtraction. It could be dividing, right? Okay, so this is inverse function. So you don't say that. You just say, because the inverse property. So what is the property that we use? Is the inverse property of logarithm. The exam or quizzes that you are going to have when you come back, you are going to have problems that you are required to write down the properties or rules that you used from step to step. Is that clear? Okay. For example, from this step to that step, you are using the product rule. From this step to that step, you're using the power rule. Is that okay? Step by step, yes. Yeah. Because you will have a box you need to fit in. Yeah. Okay, you will have instruction. All right, now let's look at the next property. Yesterday, we had learned many properties. Let's review them. Okay? Let's review all of them. Okay. Sorry? Questions? Okay. Properties of logarithm. Can anyone tell me? There are two very basic ones. Okay? Log to the base a of 1 is what? What is this? 0. Thank you. Log to the base a of a is what? 1. Thank you. Are you with me? Okay. I would say these two are so fundamental, and you learn that for more than 2 weeks. If you have log to the base 2 of x, and you know log to the base 2 of 1 is what? 0. So it's passing 1, 0. Log to the base 2 of 2 is what? 1. So it's passing 2, 1. Log to the base 2 of 4 is what? 2, right? Because 2 to the power 2 is 4. So you are having 2, 2. Log to the base 2 of a is what? What is log to the base 2 of a? 3, because 2 to the power 3 is 8. So you will have, here, sorry. How about log to the base 2 of 1/2? The answer is -1. Thank you. So you have 1/2 -1. This is an increasing function and have this vertical asymptote, right? It's getting closer and closer to the y-axis. The vertical asymptote is y-axis, and the equation for y-axis is what? X equal to 0, right? Okay. This is so fundamental. We have gone through this for weeks already. You shouldn't get this wrong. Okay? Now, I would say these two are so fundamental. Now, let's look at those properties of logs. The first one we call inverse property of logarithm. And we said already, a to the power log to the base a of m equals to m. Great job. Okay? The other inverse property of logarithm is what? Log to the base a, and then a to the power r what do you get? R. This is the inverse property. Yes. Asymptote. asymptote. Right? Because it's getting closer and closer to the y-axis. And the equation for y-axis is x equal to 0. Right? Okay. Product rule. What is the product rule of logarithm? It's a log to the base a of m times n. It should equal to what, Nathan? Log to the base a of
log to the base b of m plus log to the base b of n.
Yeah, we are using the base a right now, so log to the base a of m plus log to the base a of n. And we proved yesterday, right? And then quotient rule. The quotient rule of logarithm is log to the base a of m over n. It will become what? Is it become difference of logs? So log to the base a of m minus log to the base a of n. And you can use them now freely. Very good. The fourth one, the power rule of logarithm. Log to the base a of a, not necessary a, we could have anything. Let me make it m, okay? Log to the base a of m to the rth power. Now, this power r could be what? We can prove it, right? Actually, it's repeatedly apply this product rule. We find out that it will come out as coefficient. Log to the base a of m. All right. The last one that we are going to talk about is change your base formula. Okay? Change your base formula. Ready? If I have a log that the base a is not 10, is not e, on every calculator, or most of the calculator, we only have two bases. One is 10, one is e. If a is not those two numbers, how do we calculate that number? We are going to see there's a formula for it. It will become log to whatever base that you choose. Let me call that b of m divided by log to the same chosen base b of a. The base b could be chosen to be any number except 1, okay? And has to be positive. So for example, okay, I'm going to put example. Just write by it so that you can see. Okay? Example, log to the base 2 of 5. What is the base? 2. Okay, in our calculator, we don't have base 2. So, which base you like? You like base 10 or you like base E? You like base E? Okay, if you like base E, the base E function, we are going to give a special name. Log to the base E of x can be written as ln x. Okay? So, log to the base of E could be written as ln. So, it's called ln function. All right. Nathan likes to use base E. Fine. Then you just say ln of 5 divided by ln of 2. Do you have calculator? Please use your calculator calculating this. I heard somebody say you like the base 10. Who like the base 10? Okay, those of you who like the base 10, do this. Then you can use log 5 over log 2. Okay? Those of you who like base 10, do this calculation. And now you can tell me what are the answer. Yes? 2.321, approximation. How about with the base 10? The same, yes. Okay? There you go. So this is how we use the change of base formula. Is that all right? Okay. I will leave it. Are you using calculator for your test? Some problem. You will have one part without calculator and one part you may use a calculator. So there will be two parts. Okay. Okay, now let's do more problem. Ready? All right, example. Yesterday we have 3 examples, right? So we will start with example 4. We are going to write expressions as a single log. Are you with me? Okay, ready? Okay, this is the e to the log 24 minus, that's ln function. Okay, e to the power ln 24 minus ln 3. Wow, you say, this is the first time that we do this. No hurry, no hurry. Remember, when you do this kind of problem, no hurry. Can anyone tell me what is the exponent? It's a long expression, isn't it? Right? This is our exponent, yeah? Wow, but you like it. You say, I like it. What is that? That is difference of 2 logs. Wow. Recall, difference of 2 logs. It comes from what? A log of a quotient. Thank you. Thank you. So you say, no problem. It becomes e to the ln of 24 over 3. Yes? Wonderful job. And then you say that is just e to the ln 8, right? 24 over 3 is 8. Am I correct?
Yeah.
Good job. Now, this is the ln, which is a log with the base e, right? The input is 8. Am I correct? And then you go through log. After that, you go through exponential with the base e. Do they have the same base? Yes. So you can use what? Inverses. Inverse property, right? So you should get 8. Awesome.
That's inverse property?
That's the inverse property. Inverse property of log. Great job. How about this? This is the quotient rule. Quotient rule of log. Okay? All right. Part B. Ready? Okay? Log to the base 4 x plus 1 minus log to the base 4 x. Okay? This is a difference. So what would you do? So you become what? Log to the base 4 of a quotient. So x plus 1 over x. You are awesome. Part C. Sure. This is a quotient rule, right? Quotient rule of log. Is that okay? All right. Next. 4 log to the base 2 of A plus 2 log to the base 2 of B. Let's look at the first term. Oh, you have a coefficient 4. Yes, using the power rule, you say, da, 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 go back. And then 2, da, 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 go back. It's like pushing them back. Okay, so what do you say? It becomes log to the base 2 of A to the power 4 plus log to the base 2 B squared. Yes? What is the rule? It's the power rule, right? This is the power rule of logarithms. Now, let's see. We have a sum. You add 2 logs together. 2 logs adding together. It will become a single log of product, right? Yes. But remember, they have the same base, right? So, product, so A to the power 4 times B squared. So, product rule of logarithm. See? You have 2 terms, 2 logs. Now you combine them using the properties of logs and become a single log. Is that a single log now? Is this a single log? Yes? Okay. Now let's look at part D.
How would you ask that question on the test?
Here, can you read? Please.
Oh, right. Okay.
Write each expression as a single log using properties of logarithm. Okay? All right. It's a good question. You are right. You have to know the instruction, right? All right, part D. Are you ready, my friend? Yes. Okay. 1/3 log to the base 5 x squared plus 3x plus 2 let me give you a simpler one, okay? I decided to give you a simpler one. Can you just take away this 1/3? I'll give you a simpler one, okay? Minus log to the base 5 x plus 2. Okay. Now, how many logs do we have? How many logs we have? 2 logs, right? Do we have 2 logs right now? And it is difference, right? So it will become a single log of what? A quotient. So x squared plus 3x plus 2 over x plus 2. Are you with me?
Yeah.
You are awesome. Now, this quotient, can I simplify? It's already a one single log, but can I simplify this? How? Oh, you are so good. You factor. How you factor it? Now you tell me. It becomes what? X plus 1 times x plus 2 over x plus 2. Wow, that shows you do have very strong prerequisite, huh? The prerequisite for this class is you are able to do factorization very, very well. Okay, factorization is so important. All right, so what do we do? Can you divide out? No, you don't say cancel. You say divide out, okay? There are so many ways that you can say cancel, but we don't say cancel. So it becomes log to the base 5 of x plus 1. Are you with me? Yeah. Very good. Okay. Can I do part E here? Oh, did I say the property? What is this property? Quotient rule. Right? Quotient rule of logarithm. Okay, because we have quotient rule for other things. Okay. Now, turn to the next page.
The answer log 5 x plus 1.
Yeah, let me see. Good question. Okay, she is asking, can I go further? Yeah, it's a good question because I didn't check. Let's check. Am I done? Can I go further? Can I simplify further? This is already a single log. Yes or no?
Yes.
This is already. Yeah? We stop here. Yes, we stop here. Okay. Next. Try to well prepare you. Okay. 1/2 of 3 log x plus log y. There are several logs, and I want to make it as a single log. What do I have? Okay, so you know what? I would love you to try yourself. Give you 1 minute. You only need 1 minute, actually. You either get it right or you don't get it right, right? So try to get it right. If you're done, I can come and check. What do you do? Wow, you're awesome. Can you simplify this? Right? You can simplify it. Awesome. What do you think? 3/2. This is 1/2. Okay. Wow. But you want to make it a single log. You still have 2 logs, right? I want to have a single log, right? So you need to make a single log. Yes. Can you simplify it? Can you simplify it? Oh, okay. Yeah. He's doing it right. You want to use those rules. So either you have a sum or so look they have a sum, but then this 3 you need to make it come up here. Okay?
What do you mean by simplify?
That's, what is x cubed? Like this. This is x. Square root of x.
Oh.
I want a single log. Did I make it clear? What do I want? I want you to have a single log. Single log means what? You have to put them as 1 log, right? Okay. All right. Now, look carefully. What do I have? Let me tell you a very important tip. We want to have sum. It will be so good. Remember, we people are very good in doing adding. Okay? So try to make sure that you have a bunch of things adding together when you do this. But right now you have 1/2 times something. You say, let me make it easier. So I'm going to write it as this. So now it's a bunch of logs adding together. There's no parentheses. So you don't have. Okay, let me do this. I will tell you why I'm doing this. So now I have 2 terms. Am I correct? Okay, and I still want to make it without the coefficient because then it will be easier. So I want this coefficient back, okay? So I'm going to have log to the power to the base 10x to the 3/2 plus log to the base 10y to the power 1/2. Now I'm happy. It's very clean. The coefficients are all 1. Okay? So now it's just a sum of two logs. Are you with me? Okay. So what do you have?
Log base 10x 3 2.
I need all of you say out loud. What do I have? Log to base 10 x 3 half plus, no, not plus. What should that be? Times y to the power 1/2. This is a single log, right? Yeah? So what do you have? You have log, okay, that is x square root of x times square root of y, okay, which is log x square root of xy, okay?
Can you explain that again?
The last two steps, okay, I know. This is the hard part here, and I will definitely go over this with you guys. This is about the rational exponent. Right. I think that the other approach probably will be better for you. All right, let me tell you what is this. X to the power 1/2 is square root of x. Do you agree? Yes or no? Yes. So x to the power 3/2 is what? Is square root to the power 3. So it means square root of x, square root of x, square root of x all timed together. Therefore, you get x square root of x. Is that okay? Y to the power 1/2 is square root of y. So I would have this. Okay? Now, let me do the other way. If you have 1/2 log x cubed plus log y, then you will have 1/2 log x cubed y. Am I correct? Yes? This way is easier. And then you would say this half would just what? Go up as your exponent. So you get log of x cubed y to the power 1/2. But to the power 1/2 means you take what? Square root. Thank you. So you will have this. Right?
So you take log out? Well, we did. We put the thing over the log x3y.
Right. It has to be the whole thing.
No, we don't put it over the log then, right? Log is already supposed to be outside.
Yeah. Because you look at this, this is a sum, right? This is probably the hardest one for you guys. And then, yeah. Okay, so now let me tell you, hold on. I will not have this kind of hard one for this unit, okay? I think that we will go back to those. So let me tell you, for that part, I'll make sure you just deal with the integer for the moment. So I'm going to have a specific lesson for the rational exponent for you guys, okay? Is that good? All right. But for those of you, because this is the last chapter from the previous class, maybe, it's the last. So you did not, learn that well. But this is all about radical. Did you learn radical in the beginning algebra? Yes, you do, right? Yeah, I know. It's okay. We will come back to that. So now, this is log x square root of xy. They're the same. Okay.
Wait, where did the 3 go?
No, you already simplified. Sorry? Okay. Now, let me look at the change of base formula. Okay? Now, this part, you need to use your calculator. Can I have all of you have your calculator out if you have your calculator? Okay, let's do this. How do you do this one? This will be what? You like log, you like ln function? You like the base 10. So log 5 over log 7. For those of you who like the ln function, do ln 5 over ln 7. Should you have the same?
What are the instructions for that?
What's the instruction for this? Oh, of course. Use change your base formula to find the approximated answer. Okay? Okay? So what is the answer here? What is the answer? 0.87, approximately. 827. Do you get the same thing for this? Great job. You're going to make use of the change of base formula somewhere else as well, but right now we will focus on evaluation. How about this one? So log 5 over log square root of 2. What do you get?
So we could do either or?
Either or, right. And you should get it right. You should get the same answer, right? Log 5 over log square root of 2, what do you get? Do you know how to use a calculator? You have to know. Everybody has different kind of calculator. You cannot use phone, for sure. No, nobody can use phone during any exam. You have to have your scientific calculator, not graphing calculator either. So let me tell you, prepare a scientific calculator. I think you can get it.
Why not a graphing calculator?
Because we are asking you graphing, so if you have graphing calculator, student may cheat. Yeah. Sorry? Eventually you need one, so prepare one. Yeah. Okay? All right. Calculate without calculator is even better. So far, so good? Okay. Question? Any question? What answer for that? Oh, what is the answer? 4.64. 4.64. Okay. All right. Is that okay? Question? The previous one.
Okay. Why we can at the first multiply that 1 over 2 to the 3 and also to the 1 and then to that?
Oh, here?
Yeah.
Oh, because then you will have several logs adding together, so you just use the product rule.
And then just use that. It would be 2 log xy. Is that right?
You will have a sum of two logs combined as a single log. Just like here. If I don't have this 1/2, then this is the answer. Am I correct? See, we like to have a sum of two logs which are very clean. There's no coefficient. The coefficient will be 1 here. Okay, we like to have a sum of several logs that they all have 1 as their coefficient. Then we can directly using the product rule and get the answer right away. Is that okay? All right.
So first go to get rid
The coefficient, yeah. So I can show you one last one just because you asked that. That's a very good question. Let me show you. Okay. Just one more. Okay, for example, I'll give you an easy one. 3 log x minus 2 log y minus 5 log z. All right, 3 terms. What would you do? Can I have you do it in 1 minute? Okay. What would you do? See, you have difference. So what would you do? Be careful. First, you will take the coefficient and use the music play backwards, right? Back. 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 Okay, so what do you get? You get log x to the power what? 3, and then minus, and let me tell you, and remember I said, a lot of people like to have a sum. So they are going to make this as a sum. Just take the whole coefficient up. So you would have add log to the log y to the power what? -2, and then add log z to the power what? -5. So that you have a sum. You have a sum of many logs. Is that clear to you guys? Now, because it's a sum, so all you need to do is what? Using the product rule, right? So it will become a single log of a product. X cubed, y to the power -2, z to the power -5, right? Is that okay? And then, just say that is x cubed over y squared, z to the 5th.
Oh, because it's negative, right?
Because the power is negative. Is that okay? Because in the past, a lot of students making mistakes because when they see this difference, they do very weird things. They're just not getting those straight because you are continuously subtracting. You have to be very careful. Okay? Yeah. Either way is fine. Thank you so much. And let me tell you the homework. You will finish all 8.4. Okay? All. And I will have quizzes as well over there, short quiz. Okay? From now on my math lab. And now we are going to go back to the chapter 4. Chapter 4, we are going to do 4.4, the pre-reading. And let me tell you, actually, this is something that you have already, learned. Okay? In your previous course.
That's enough. I have an essay this weekend.
Sure. Yeah. Tuesday, no class. But I want you to have student group meet.
Is it after reading?
Sure. No class on Tuesday, but you need to have a study group. You will have a study group packet. Okay? You will have a study group packet. You work together. It's going to be uploaded to Canvas. Okay? Are you meeting all that outside of class time? Okay, you should. For Tuesday, why don't you try, since that's a regular study day, I want you to really study. Can you connect with each other? And then on Canvas, I think you can discuss with one another. Can you tell me if you don't know which group you belong to? Anyone do not belong to any group? Okay. Do you have a group? You don't? Okay. All right. I'm going to see. Who are in your group? Stand up with your group mate.
Claire is here, and then it's you, and I don't know who the other.
Stand up for the people study with Nathan. One? Only two? Okay. Can I have two of you join them? Okay. Claire. Well, Claire not here today, but can you exchange your information? Okay. It will be a wonderful group. How about the group here? It's a giant group. Great job. Okay. Who is the mentor here? Okay. All right. Make sure. Okay. And how about who is the mentor this time? Now this is unit 2. Okay. You. So you're in charge of that packet. Okay. All right. How about here?